Hi everyone, so in this video we are going to be talking about translations. So before we talk about them too far, first off we are going to be given some functions and we are just going to plot them by plotting some points. So just like we did whenever we did the parent functions, we're going to do the exact same thing, only now it's a little bit more than just the parent. It has some other numbers with it. So to start out, we have x squared minus 4. So just like we did with parent functions, we're going to pick some x values. In this case, I did already pick some x values for us. We're going to plug them in to get the y values, and then we're going to plot each one of those points. So let's get started. So negative 2 squared minus 4, if we plug in negative 2, is going to be 4 minus 4, which is 0. Negative 1 squared minus 4 is 1 minus 4, which is negative 3. 0 squared minus 4, 0 squared is just a 0. So 0 minus 4 is negative 4. 1 squared minus 4 is 1 minus 4 again, which is negative 3. And 2 squared minus 4 is 4 minus 4, so that's 0. Okay, so let's go ahead and plot these points, see what we have, and just keep in mind that this is x squared, so we would probably expect something like that U shape, the parabola that we got whenever we did the parent functions. So if we plot these, we have negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. If we draw that same U shape to connect all of these up, then you can see it's the same exact shape as before, but specifically what happened to it? Well, in this case, it usually starts up here at 0, 0. That's where the turnaround point is. So it's something like that normally. Well, it just got moved down. Specifically, it got moved down 4 places. Okay, so domain, still the same, negative infinity to infinity, still arrows on the left and right. Range, lowest it goes is now negative 4, still to infinity. All right, so let's go ahead and look at another one. The absolute value of x minus 2. All right, again, I gave you some x values to plug in already, so we're going to use these. So this is going to be an absolute value of 0 minus 2, which is the absolute value of negative 2, which is just 2. Absolute value of 1 minus 2 is the absolute value of negative 1, which is 1. Absolute value of 2 minus 2 is the absolute value of 0, which is 0. Absolute value of 3 minus 2, the same as the absolute value of 1, which is 1. The absolute value of 4 minus 2 is the absolute value of 2, which is 2. Okay, again, if we think back at our parent functions, we had an absolute value of x, right? So we expect it to look something similar like that, still that V shape. So let's go ahead and plot these and see what happens. So we got 0, 2, 1, 1, 2, 0, 3, 1, 4, 2. again, we can see that it does in fact make that V shape. So we can go ahead and draw the V. But what happened to it? Normally the V shape is here. But in this case, it moved to the right 2. Again, just something to keep in mind for now. Let's go ahead and do domain and range. So domain, arrows on the left and right. So negative infinity to infinity. Range, lowest it goes is 0. Highest it goes is infinity. All right, let's look at one more before we start talking about actual transformations. So this one's going to be the square root of x plus 1 and then minus 3. Again, I gave you a few x values, so these are going to be the ones that we plug in. So we have the square root of negative 1 plus 1 minus 3, which is the square root of 0 minus 3. So that's just 0 minus 3 is negative 3. All right, the square root of 0 plus 1 minus 3 is the square root of 1 minus 3, which is just 1 minus 3, which is negative 2. All right, last one. Square root of 3 plus 1 minus 3 is the square root of 4 minus 3, which is 2 minus 3, which is negative 1. All right, keep in mind, this looks like the square root of x. So we have that kind of eyebrow looking shape. So if we plug these, plot these points, let's see what we get. So it's going to be negative 1, negative 3. It's down here. 0, negative 2. 3, negative 1. And we can see, we can draw that same exact eyebrow shape through it. Right? The difference is normally it's here. So what happened to all these points in this case? Well, they moved down 3 and then to the left 1. So do we see anything that could have caused them to go down 3 and left 1? And we'll get to it in just a second. Domain. So again, we're just looking at the blue one right now, the one that we graphed. For the domain is going to be negative 1 is the farthest left to infinity on the right. The range is going to be negative 3 at the bottom to infinity is the highest. Okay, so with all of that said, let's go ahead and talk about some translations. And in particular, we are first going to talk about vertical shifts. So a vertical shift is something that moves the graph up or down, right? If you have some parent function, so that could be x squared or the square root of x or the absolute value of x, and you have either plus some number or minus some number that is outside of the function. And by outside of the function, I mean this number is not being squared. It's not being cubed. It's on the outside of that, right? If you have that, all that does is move the graph up or down that many. So if you have x squared plus k, it would go up k. if you have something like x cubed minus k, it would go down k. All right, so let's try a couple. So for this first example, we have x squared plus 3. So first thing that we're going to do is we're going to graph x squared. Right? Now, if you have multiple colors, I highly recommend using multiple colors for this. If you don't, maybe make the parent graph just dotted, though you know it's not your final answer. All right? Because the first thing we're going to do is we're going to graph the parent, which is x squared. All right? So ignoring that plus 3, it would just be x squared, which we know how to graph. All right? So the points for x squared are 0, 0, negative 1, 1, and 1, 1, and negative 2, 4, and 2, 4. Those are the 5 points that we've graphed for x squared. The good news is as long as you know that graph, then dealing with this plus 3 is really easy. This just means that we're going to go up 3. That's it. Right? So every single point that we just graphed, we're going to move it up 3. So move this one up 3, this one up 3, that one, and that one. Again, you can just see I literally just moved each point that we had already graphed up 3. That is going to be our new graph. So the blue is f of x. That's our final answer. The domain of that, still negative infinity to infinity, but the range, because we moved it up 3, its lowest point is now at 3. Still goes all the way up to infinity, though. All right, let's try another one. So example 2, the absolute value of x is the parent. So let's graph that first. We got 0, 0, negative 1, 1, and 1, 1, and then negative 2, 2, and 2, 2. And it makes that V shape. All right, so what's happening to it? Well, minus 4 means it's going to go down 4. So remember, plus means up, minus means down. So we're just going to take every single one of these points and we're going to move them down 4. Again, just taking every point that we already plotted and counting straight down 4. That's how I'm getting here. Then we draw the same exact shape. So it is still a V. It's just been moved down. So domain and range. The domain, still negative infinity to infinity. The range, since we moved it down 4, is now negative 4 to infinity. All right, that was vertical shifts. So now we're going to talk about horizontal shifts. So horizontal shift, first off, you can tell it's horizontal because whatever the number is going to be inside the function this time. So for example, it's going to be inside the absolute value instead of just on the outside tacked onto the end. Or it will be inside whatever's getting squared. Right? Now, the weird thing about horizontal shifts is they do the opposite of what you think they should. So usually negative is to the left and positive is to the right. For shifts, though, you have to reverse those. So x minus h means that we're actually going to shift it to the right. X plus h actually means that we're going to shift it to the left. Okay, so let's go ahead and try a couple. So we're starting out with the absolute value again. It's the absolute value of x minus 4. All right, so we're going to start by doing that parent function. Again, that's 0, 0, negative 1, 1, and 1, 1, negative 2, 2, and 2, 2. And this is our parent. All right, now we have minus 4. So remember, opposite of what you think it should be. So normally negative means left, but since we're doing the opposite, this is going to be right 4. So every single one of these points, I'm going to move to the right 4. So you can literally just count them over just like we did before with up and down. All right. So once we have that, we can go ahead and draw our same V. And we are good to go. The domain, still negative infinity to infinity. Left and right are still arrows. In this case, the range is actually the same as well because it didn't move up or down any, it just moved to the right. That won't affect the minimum. So it's going to be 0 to infinity still. All right, let's try the next one. Square root of x plus 2. So again, parent function first. The parent function would be the square root of x. So if we go ahead and graph the square root of x, it's 0, 0, 1, 1, 4, 2. We can go ahead and draw it like that. This time we have a plus 2. Plus 2 means that we're actually going to move to the left 2. So again, we're going to take these 3 points that we have, and we're going to move them all to the left 2. Draw our new graph, and we're good to go. The domain, this time we did move it to the left, so our leftmost point is not going to be the same. It is now going to be negative 2 to infinity. Didn't move it up or down though, so range is still 0 to infinity, just like the parent. All right. Let's go ahead and start putting these together now. So we're going to start these the same way. We're always going to start with the parent. In this case, the parent is x squared. So we'll put that down first. 0, 0, negative 1, 1, 1, 1, negative 2, 4, 2, 4. And draw the U-shape. All right, what's happening this time? There's actually two things that are happening. It's left 2. And then we also have a down 4. Luckily, we can go ahead and do both of these at once. So for each point, I'm going to move left 2 and down 4. So again, for each point, I literally just went left 2, down 1, 2, 3, 4. That's how I got to the next point. And I did those for all 5 points. Then we just draw our U shape back through those new points. All right, domain and range. So the domain, negative infinity to infinity still. The range, our lowest is now negative 4, all the way up to infinity. All right, one more for this video. So our next parent is the absolute value of x again. So 0, 0, negative 1, 1, 1, 1, negative 2, 2, 2, 2. And we draw the V shape through it. And we see what's happening with it. Well, negative 3 means right 3. And a negative 5 on the outside means down 5. So from every one of these points, we're going to go left 1, 2, 3, and down 1, 2, 3, 4, 5. If we do that for every single point, we end up with this. I'm sorry, I said left. We were supposed to be going right. Apologies. So if we go right 3 and down 5, we should actually end up here. Draw our V shape through it, and we're done with it. Domain, negative infinity to infinity. The range, the lowest is now negative 5, still goes up to infinity. All right, so in part 2 of this, we're going to do a couple more examples of this. Then we're also going to do one more type of transformation, which is called a reflection. All right, with that said though, I'm going to go ahead and end it here for this one, and I will see you in part 2.